All right, in this example, we're going to explore long-run behavior and limit notation and apply it to an exponential function, and also talk about horizontal asymptotes. All right, so long-run behavior. Long-run behavior of a function is just the behavior of the function as x gets bigger and bigger. Either in the positive or negative direction. So it either approaches infinity or negative infinity. And we have a notation for that in mathematics, the limit notation. So we say here that we're looking at the limit as x approaches infinity of f of x. All right. Or the limit as x approaches negative infinity of f of x. So we're looking at, it's sometimes called end behavior as another name for long run behavior. But we're looking at we're looking behavior. We're looking at what happens to f of x in the long run, right? Either as x gets bigger and bigger in the positive direction or in the negative direction. All right, so we're going to look at this function y equals 4 times 0.8. So this is an exponential decay, 4 times 0.8 to the x. All right, so this is an exponential decay, and I just chose a few values here, and I want you to sketch a graph of the function. Now, I'm actually just going to start in the middle, because I know when x is equal to 0, 0.8 to the 0 is 1, so I have a value of 4. And then for x equals 1, it's just 4 times 0.8, so we end up with 3.2. And then if x is 10, we get 0.43. All right? Those are easy to calculate. If I try to put in 100, right, I get a very, very, very small number. In fact, it'll come out in your calculator as, I think it comes out to be 0.00000000815. I think there are 9 zeros if I remember right. But it's just very small. Very small. All right, so I'm just going to write very small because I'm not going to be able to graph that. So, all right, let's look at the other direction when x is negative. All right, so remember 0.8 to the negative 1 is, it's just the reciprocal of 0.8, so 8/10 becomes 10/8. And then we multiply times 4, and the result is 5. And when we put in a negative 10, you can just put these into your calculator. I got 37.25. All right, if we try to put in a negative 100, right? So it essentially becomes 4 times 10/8 to the 100th power, right? The negative just flips the 8/10 to 10/8. It becomes a very, very large number. So you can try putting in your calculator to see you'll get a big number. So I'm just going to write very large because I know I'm not going to be able to graph it. Because we also want to graph this function. So I'm going to try to draw here an x and y axis. Well, let's see. I don't think I want to do. I think I'm going to use. Let's do this. Oh no, draw. Let's actually use. Let's just escape. All right, maybe not. Maybe I'll just do it with a pen. Here it might be easier. All right, let's just do it with a pen. I'm going to draw an x and y axes. All right. All right, so here's my x-axis, here's my y-axis. And okay, so I would need the y to go from 0 to 37. So let's make this 10, 20, and 30. All right. And then x, I'm not going to worry about going to 100, so I'm just going to, we'll just do 5, 10, right? And do same here, negative 10, negative 5. All right, so let's try to plot these points and sketch a graph. So when x is equal to 0, we're at 4, so maybe about there. And then we're at 10. Let's see. Sorry, at negative. Let's do negative 1. Okay, so negative 1's probably about here. We're at 5. Well, that's not 5. It's got to be lower than that. It's not very much above 4, given the scale. And at, let's see, positive 10, we're at 0.43, so it's kind of small here. It's about there. And at negative 10, we were at 37. So I don't know, let's say 37 is about here. All right, so I'm just going to connect these with a graph. So, okay, I just wanted you to get the sense of the graph. So yeah, that's fine. It's not, I have a little bit of a wiggle here that I don't really like. It says it looks like it's becoming linear, but it's got a constant curvature. Let's just do this. Let me fix this end of it. I don't like that end. So it's going to have more of a curve to it. All right. So there's a sketch of the graph. All right. Now let's think about these questions that are down here. Is there any value of x for which y is equal to 0? All right, so let's take a look at, well, yes, this function is 4 times 0.8 to the x. 0.8 is a positive number, and any power of a positive number is going to be positive. And there's really no exponent that will make this 0. So the answer here is no. This graph never falls below 0, never falls to 0, never gets to 0. There is no x-axis, or no x-intercept. So no x-intercept. And it's actually never going to be negative. So that's actually the second question here. Is there any value for x for which y is less than 0? So is y ever negative? No, because we're taking 4 times a power of a positive number, and there's no exponent, not even a negative exponent, right? Negatives just make a reciprocal, so even negative exponents are going to make a positive number. So this one is also no. All right, so that tells us something about the domain and range of the exponential function, right? The domain, right? We can put any value of x in, right? From negative infinity to infinity. And we can calculate a value. There's no restrictions on x. The range, however, right, what are we going to get out? The range is the set of all possible outputs of the function. And we're never going to get 0 or a negative value for x. But when x, you can see when x grows more and more negative, you could see that here when we try to put in negative 100, we just get a very, very large number. And so for negative values, it's going to grow to infinity. It's just going to keep growing and growing. So y is greater than 0. Okay, so that's the range of our function. All right, now that brings us to the concept here of a horizontal asymptote. So the definition of a horizontal asymptote is if the limit in this end behavior, right, is the limit as x approaches infinity or minus infinity, if the function approaches some constant value k, then the horizontal asymptote is y equals k. All right, so here we have it's not really part of the question, but we have the limit as x approaches infinity of this, did I name the function? I don't know if I named it. No, I didn't. So I'm just going to call it f of x. What is that? It's equal to 0. All right, it goes to 0. It approaches 0. It gets smaller and smaller and smaller, but it never gets there. So y equals 0 is the horizontal asymptote. Asymptote of this function. So this exponential function has a horizontal asymptote of y equals 0 because if x approaches infinity, y approaches 0. All right, so that's the idea behind a horizontal asymptote. All right, I'll meet you in the next video for more discussion of horizontal asymptotes and long-run behavior.